Alright, so now that we know how to go from the formula to the name for our two different types of metals, variant and invariant, now we're going to go from the name to the formula. And that's one of the first things we started doing when we did our naming chapter. We went from, if I gave you two ions, writing the formula from those two ions. So our steps are going to be very similar to those initial steps. But we had to learn what all of that meant because now we have a more formal name when before we just knew what two ions were there. So let's review our steps. Remember the step was for the cation. We want to write the symbol and the charge. That was our first step. Okay? So that was our first step if you go all the way back to the very beginning. So to figure this out, remember if it's always going to be metal, non-metal, okay? Unless it is a molecular compound. So first we want to figure out, well, we see this. There should be a big sign that it's a metal because the only thing that's going to have that in there is going to be a metal. So then I have to figure out what manganese is. And so that's where you have to realize, well, what are your choices? You can do that if you don't know the names. It's obviously not this guy because that's magnesium, okay? And manganese doesn't have an O, so it's this guy. But you need to know the names, okay? Formulas and names. So we write Mn, and then we know his charge because it told us it's charge because he's variant. If he was invariant, then we would just know based on where he was in the periodic table. Step 2 is for the anion. We have to write his symbol and charge. So it's sulfide. So we know if we drop the I, it's sulfur, and that symbol is an S. And to figure out the charge, we go over here and we look, where's S? He's in this group, which is a -2 charge. Okay, so he's a -2. Step 3 is my cross down method. And so you can just write it cross down. So then I get Mn2S4. Okay. Step 4 was to reduce those subscripts. So I can actually reduce these. I can reduce it all by a factor of 2. So that would give me MnS2. Because remember, ionic formulas are empirical, not molecular. So I need to have just the ratio. So divide by 2 to get MnS2. And then step 5 is my check. I have 1 Mn at a +4, gives me a +4. I have 2 sulfurs at a -2. That gives me a -4, adds up to being neutral. So that would be my formula. So my final answer would be MnS2. All right, let's do some more practice. Same steps that we just did. Okay, so let's figure out the first. So copper 2 ion with a nitride ion. So this looks a little bit more like what we did the first time. But if you see, you had to understand how to name so you would know what these little parentheses meant. Okay, so you could see it like this with the ions, or you could see it with the full name. But either way, you should be able to write it out. All right, copper 2 ion with a nitride ion. So we look at the first one, we think, okay, what is the symbol for copper? So the symbol for copper is Cu. It tells me the charge, +2. Nitride, and that, I know nitrogen. Symbol for nitrogen is an N. To get the charge, I go to the periodic table, and he's in this group. So he's got a -3 charge. So then I'm going to cross down Cu3 and 2. Can I reduce that? Nope. So then I do my check. 3 Cus at a +2 gives me a +6. 2 Ns and a -3 gives me a -6, so I'm good. So Cu3 and 2 would be exactly how you would write that. All right, let's do the next one. Iron 3 ion with a bromide ion. So what's the symbol for iron? Fe. tells me the charge, so I don't even have to go to the periodic table. It tells me it right there, so just write it down. Bromide, end that, so it's bromine. The symbol for bromine is Br. Go to the periodic table, find Br. Here he is. So he's a -1. So Br is a -1. Cross down. I get FeBr3. Can I reduce that? Nope. I do my check. I've got one Fe at a +3, gives me a total of a +3. I've got 3 Brs at a -1, gives me a -3, so neutral. So there's that one. So copper 3 ion with a nitride ion and iron 3 ion with a bromide ion gives me Cu3N2 and FeBr3. All right, so that is how to go from the name to the formula. So far we've done everything when it comes to ionic except for polyatomics. We've done if the cation's a metal invariant, if it's a metal variant, and then the anion being a nonmetal. The only thing left we have with ionic is to do polyatomics. So that will be the next lecture, is to talk about what is a polyatomic ion.